Today we will talk about process control block. PCB is a data structure used by computer operating system to store all the information about a process. Information associated with each process also called task control block. 1 process state, 2 process number, 3 program counter, 4 CPU registers, 5 CPU scheduling information. Define the status of a process when it is suspended, allowing the OS to restart it later. As a process executes, it changes state. New, the process is being created. Ready, the process is waiting to be assigned to a processor. Running, instructions are being executed. Waiting, the process is waiting for some event to occur. Terminated, the process has finished execution. Only one process can be running on any processor. Core at any instant. Many processes may be ready and waiting. Talk about the location. What is the location of PCB? Location of the process control block is the PCB is kept in a memory area that is protected from the normal user access. This is done because it contains important process information. Some of the operating systems place the PCB at the beginning of the kernel stack for the process as it is a safe location.
Why multiprogramming is one of the most important aspects of an OS is the ability to run multiple processes.
To increase CPU utilization. Also to keep users satisfied.
As a single process cannot, in general, keep either the CPU or the I/O devices busy at all times. An I/O-bound process spends more of its time doing I/O than doing computations. A CPU-bound process uses more of its time doing computation. What is the idea of multiprogramming?
The operating system keeps several processes in memory simultaneously. The numbers of processes currently in memory is known as the degree of multiprogramming. The operating system picks and begins to execute one of these processes. The operating system keeps several processes in memory simultaneously. The numbers of processes currently in memory is known as the degree of multiprogramming.
Eventually, the process may have to wait for some task, such as an I/O operation, to complete. In a non-multiprogram system, the CPU would sit idle. In a multiprogram system, the operating system simply switches to execute another
Give an example. Multiprocess architecture.
Websites contain active content that software bugs. If web browsers ran as single process. If one website causes trouble, entire browser can hang or crash. Google Chrome browser is multi-process with 3 different types of processes. Browser process manages user interface, disk and network I/O. Renderer process renders web pages, deals with HTML, JavaScript. A new renderer created for each website. Open plugin process for each type of plugin such as Flash or
What is the relation between the size of PCB and system throughput? At first, what is throughput? Throughput measures the data transfer rate to and from the storage media in megabytes per second.
Let's see the relation. When multiple processes are running, the CPU has to determine which process runs next in order to utilize resources and optimize system performance. For example, some processes spend more time doing I/O, which takes long time, other processes take more CPU time, so it does not make sense for an I/O-bound process to block other process from having access to the CPU. Depending on operating system design goals and behavior of the running processes, different parameters can be computed to get an idea how the system is performing.
In OS context, throughput refers to the number of completed processes in a given amount of time. Let us take an example. Assume we have 3 processes that we need to run in the order they arrive. The first process, P1, takes 5 seconds to finish, the second process, P2, takes 15 seconds and the third process, P3, takes 10 seconds. Throughput in this case, 5 plus 15 plus 10/3 equals 10, on average, one process is completed every 10 seconds.